Hi and welcome to Demon Questions from OnMaths, where we look at the more challenging GCSE maths questions. Enjoy! The way you structure this is there's 20 marks on each Demon paper. We're either doing non-calculator or calculator, higher or foundation. And within those 20 marks, I've evenly distributed the topics and I've evenly distributed the grade. So it starts at a low grade and gets higher. I've also put the grade boundaries on so you can roughly estimate whereabouts you are. I hope you enjoy. Thank you.
So this question asks us to write the smallest odd number. Now there's two instructions there. We need to make the smallest number from the digits and it needs to be odd. So to make the smallest number, we want to use the smallest digits on the left hand side of the number and the largest digits on the right hand side of the number. Okay. We also need the last number to be odd. Now to make a number odd, the last number needs to be 1, 3, 5, 7 or 9. Okay, so looking at the largest numbers, the largest number is 6, so we want to end on a 6. However, 6 is an even number, therefore if we end on a 6, it will be an even number. So we've got to look at the largest odd number, which is the 5. So the 5 is going to go here to make the number odd. Then we need to use up that 6 next. And then the next largest number is the 4, and then 3. So my answer is 3,465. Now always just check to see whether we've answered the question. It says it wants the smallest odd number. Well, that's an odd number, and I can't think of a way of swapping those digits to make it any smaller because we've used the smallest numbers we can on the left hand side and the biggest on the right hand side. So it asked for an even cube number. So the cube numbers are 1 cubed is 1 times 1 times 1, which is 1. The problem is that is an odd number, so let's try 2 cubed. Now 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 8 is an even cube number. Now you could have also had 64, which is 4 cubed. 6 cubed is above 100, so that would not count. So 8 or 64 are the correct answers. Okay, for this question we're asked to find the cost of the toffees and the fudges. Now, if we imagine that we had 2 toffees and 3 fudges, how would you work this out? Well, the cost would be 2 times 50p, and then we would add 3 times 70p. The problem is that 2 and 3 I've just made up, so that's not going to be the answer to this question. What it says though is that it wants toffees to be called T and fudges, the amount of fudges, to be called F. So instead of 2 toffees we have T toffees, and instead of 3 fudges we have F fudges. And in algebra we always put the number before the letter and we don't show the time sign. So it's 50T plus 70F. Now be careful, it does want the cost in pence, but sometimes it wants it in pounds. So if it wants it in pounds, it'd be 0.5T plus 0.7F. So the answer is C equals 50T plus 70F. And that can be either way around. Okay, so the first thing to realise with this question is what perimeter means. Perimeter is the distance around a shape. Now we've got a lot of x's and numbers, but it does say it wants an expression for the perimeter. So we're not looking for a number as an answer, we're looking for an expression, so letters and numbers. Okay, so there are a few sides missing, so I'm going to try and find out this side first. And to get this side, we're going to add the 5x here with the x there. So 5x plus x is 6x. So we've got that one. Now, if the total distance across is 7x plus 16, and the bit we know is 6x plus 11, then the bit we don't know we'll have to add up together to make the 7x plus 16. So we need another x and we need another 5. Okay, we've labelled all the sides. So what I'm going to do is pick a point on the shape, and I'm just going to start walking around the shape and writing down everything as I go. So perimeter equals, and we've got 6x plus 11 plus 5x plus x plus 5 plus 6x plus 7x plus 16 plus x. So we've got quite a lengthy string of algebra there. Now we'll always need to simplify this. Okay, so if I collect the x's first, so we've got a 6x plus a 5x plus an x plus 6x plus 7x plus an x, which is going to be 26x. Okay, let's do the numbers next. So we've got 11 plus 5 plus 16, which is going to be 32. Okay, so the perimeter is going to be 26x plus 32. Now, a different way I could have done this is just focused on this one and doubled them. Now, let's have a look and see how that works. If this length here is 6x, then these two here would add together to make 6x. So in total we have 12x going down. All the ones going across is going to be double this one. So it's all going to add together to make 14x plus 32. And then if you add those together, that would also give us the 26x plus 32. Okay, so this looks like a really simple question, but it's not that simple. If you have a look at the triangle itself, the problem we have with it is to work out the area, we do the base times the height. But the problem is we haven't really got a base and a height that are at right angles to each other. Okay, and a base and a height must be at right angles. So we can't really use that method at all. So we've got to find a different method for doing it. Well, you could say, well, let's count the squares, but a lot of the squares are kind of fractions of squares that we don't quite know. The way I'm going to do this, and if you've got a different way it gets you the right answer, stick with it, is I'm going to work out the area of the square, so the whole thing, and I'm going to take away the area of the triangle A, B, and C. So when I do that, it leaves that triangle in the middle. So if you have a look, there are little triangles. So triangle A is this one here. So there's little triangles around it. So this is triangle A here. Triangle B is this one. Not done a very good job with that. Let's try again. So triangle B is this one here. And then triangle C is this one here. Now you need to be quite good at being able to remove the bits you don't want to get the bit you do want, and that's quite a common theme with these kind of questions. So I'm going to work out the areas of each of the triangles. So triangle A, the area is where it's 2 squares across and 4 squares up. So it's half of that, so it's half times the base, which is 2, times the height, which is 4. So that's going to be 4. Triangle B, the area is, so it's half times the base, which is 2, because it's 2 across, and the height, which is 2, because it's 2 squares up. that's going to be 2. And then triangle C, the area is going to be half times the base, which is 4, times the height, which is 2. So that's going to be 4 as well. Now the total area, the square area, is just 4 times 4. So that's the whole thing, which is obviously 16. Okay, so the area of the triangle is the square take away the bits we don't want. So take away triangle A, B plus C. So the square is 16, and we're going to take away the bits we don't want. So that's 4 plus 2 plus 4. 4 plus 4 is 8, plus 2 is 10, so it's 16, take away 10, and that leaves 6. So the answer is 6. Now there might be other ways you can do this. The most common wrong method for this question is working out the area of the square, which is 16, and then halving it to make 8. That would work if, for instance, and I'll draw it on here, if you had a triangle like this, that would work, because if you have a look, the height is there and the base is here, therefore they are at right angles, so that would work for that. Ooh. There we go. But unfortunately there's no way of doing that method for this question, and so you've kind of got to find the total area, find the bits you don't want and take them away, and it leaves the bits you do want. Okay, so this question looks a little bit complicated, in fact very complicated, but whenever you have this type of question where you've got different categories of people or items, the best method and the clearest method is to draw a quick two-way table, which I'm going to do now. So I'm going to draw a quick two-way table, and the options for the people are either they are male or they are female. We'll add a total column or a total row, and they either do maths, English, science, and again I'll add a total as well. Okay, so I can add some lines in as well. In fact, let's do a different colour to make it a bit clearer. Okay, the absolute total is 123. Okay, and we just go through and fill in the bits we do know. So 57 of the students are female, so 57 females. 15 of the 36 students who went to English were male, so there's 36 students who went to English, and 15 of them were male. 33 students went to science, and 29 males went to maths. So 29 males went to maths. Okay, what we asked for, so we're looking for the females who went to science. So if I highlight that, so females who went to science. So we're looking for this one here. Okay, so what you can do with this question is just try and fill out the bits that you can, right? So I'm going to start off with this top one here. Okay, and there's different ways of doing this. Now, if there's 123 students in total and 57 of them are female, then 66 of them will be male. Okay, because these two here have to add up to 123. Then if there's 66 males in total and 29 of them went to maths and 15 of them went to English, then that leaves 22 who went to science. And if there's 22 males who went to science and there's 33 people in total who went to science, then there's going to be 11 females who went to science. Now, there's different ways of doing this question, and actually you didn't need to do a two-way table for this question. It's just a lot easier to check your answer, and I find it a lot quicker. So if you have this type of question, a two-way table is probably the way to go. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Now this question doesn't look like it gives us an awful lot to go on to answer it. However, it does give us enough. Remember, we're looking for an expression for the area of the triangle. So we're not looking for the actual number. We're looking for something like 5x squared or something. Okay, so most important thing to realise at the start is that m is the midpoint. And we need to start labelling the sides. So if the total height is 24x, then this bit here will be 12x. And this bit here will be 12x because m is a midpoint. Now, second most important thing to realise is it's a square. So the base and the height of the square are going to be equal. Therefore, it's going to be 24x across the bottom here. And we've used up an x at the top left bit. So we're going to have 23x left over. Okay, now, the way of doing these questions is you work out the area of the whole thing, okay, so the whole square. That's a dodgy looking square, but anyway, and you remove the bits that you don't want. Now the bits I don't want is that top triangle there, this bigger triangle here, and then the bottom triangle here, okay, and I can label them A, B and C. Okay, now I'm going to work out each of the triangles. So triangle A I'm going to start off with. So the area for triangle A is half times the base, which is x, times the height, which is 12x. Now x times x is x squared, and half of 12 is 6. That's going to be 6x squared. Triangle B, the area is going to be half times the base, which is 23x, times the height, which is 24x. So we know it's going to be x squared again, so the 2 x's, but I just need to do 23 times 24 times a half, or I can half 24 to make 12 and then times by 23, which is going to be 276x squared. Triangle C, okay, so same thing again, half times the base, which is 24x, times the height, which is 12x. And again, it's a very similar question to the one before. So we're going to do x times x, which is x squared. And we're going to do half times 24 times 12. Or I could halve the 12 and then 12 times 12. Sorry, half the 24 to make 12. 12 times 12 is 144. Okay, so the total area, so total triangles, is going to be 6x squared plus 276x squared plus 144x squared. So I'm going to add up all the bits we don't want, okay, which is 426x squared. Okay, so the bits we don't want is 426x squared. Now the total area is going to be the width of the square times the height of the square. Okay, so square area equals 24x times 24x. So the x and the x make x squared, and I've not left enough room there, and 24 times 24 is 576. Okay, so the shaded area is going to be the total square area, which is 576x squared. Take away the bits we don't want, which is 426x squared. So 576, take away 426, which is 150 x squared. So my answer is 150 x squared.
I hope you enjoyed that video, and if you really liked it, click like. If you really liked it and want to see more, click subscribe. All these questions are on our website, onmaths.com. So if you go to onmaths.com, go to STEAM and questions, you can have a go on this paper yourself. Obviously the numbers change like everything on OnMaths, so you can keep trying it again and again until you get full marks. Thank you very much.